Shake Table Lab by Tirel Jackson and Emilia. Tirel and I had to create a simple sketch of what our tower was going to look like. We both used Sketch to finalize our design, and we put our guessed measurements on what size our tower's dimensions would be. Our ideal total length was going to be 36 centimeters. That would be too short. Each floor was going to be 18 centimeters without the roof. This was our ideal measurements before our new building codes came in. When Tirel and I both walked into science class one day, we found out there was a new building code. Now we had to attach straws on the bottom of the tower and bend them against the flat surface. Then we needed to tape them into place and had created our foundation bolts. These bolts help support the first section because it gives the four corner joints extra support. It adds stiffness and more strength. A very important part of being able to attach our straws is having tape. Tirel and I had to add more tape in some places and less in others. On the main corner joints, we noticed more tape was placed there and that there was less tape on the X crossbeams. Putting tape wasn't a piece of cake. We had to really think about how much tape was necessary and where it wasn't. Here is our tower without its roof yet, and you can still see its main corner joints. We thought the tower would do better if it had X crossbeams across each side. Under each floor, we taped two straws like a cross and taped them to the paper. Now we know that by putting more support on the sides would be better. Now that I look at the tower, I think we should have put some more support under each floor. The floors felt a little flimsy, and I think some more support would have been much better. Our roof isn't very fancy. It's a little weak. We didn't pay much attention on our roof as much as we did on the main body of the tower. Our tower has some pinwheels and a flag. It is a little plain, but I think the roof didn't matter as much as the tower itself. The new building code said that each tower's roof had to be unique and different, and that's what we did. After measuring our tower, we came to the total height of 68 centimeters. Using Sketch, we put each story's measurements and height. I almost made the mistake of measuring the tower in inches. That would have been bad. The whole tower looks pretty crooked, and the roof isn't straight at all. Looking at the full tower's height, I can totally see that indeed our tower is really crooked. I think it was frustrating to measure all the different stories since we had to do them one by one. Each story was almost always a different measurement, so we ended up having different numbers when we were adding up the total height. Static testing was making sure that the floors on the first and second story would hold a sandbag. You had to be really careful though, because if your floor ripped, you wouldn't get any more straws to rebuild. Testing went well for us, and we actually got 2 sandbags on each story. Our second story is very flimsy, and so I'm hoping that it doesn't rip when we test our tower. If it ends up ripping through the second story, then those 2 beanbags will fall on the first floor. Tirel and I think that the weight will probably be too much, and then our tower will be ruined. Our tower's main corner joint had lots of straws coming out of it, and so it needed extra strength. My partner and I decided to put extra tape wherever it needed more. When we had to attach another straw coming out from the main corner joints, we always added more tape, and sometimes even extra. The several strips of tape were all positioned differently. Some pieces went around the straw, while other pieces didn't. Tirel and I agreed that the X cross joints and main corner joints were the strongest. We both noticed how sturdy and important they were for the whole tower. The corner joints add strength to all the other straws. They are like the main body of the tower because all the other straws are connected to them. Each X joint adds a lot of extra strength to the sides of each floor. These will add balance and more support to the main 4 corner straws of our tower. I think that the story right below the roof is the weakest. The roof doesn't have X joints on any of the sides and is very flimsy. Thankfully, we aren't putting any weights on that part. The shaking might cause this part of the tower to shake and collapse. I think this might be a big problem and that we should have added X joints. The part of our tower that has a lot of tape is the 4 main corner joints. When Tirel and I had to tape our paper floors into place, we used a lot of tape. We had to make sure that there was enough support on each side of the frame. On the first floor's frame, we put a lot of tape around the edges to keep it flat and sturdy. Getting extra materials was great and very useful. Paper wasn't something I expected to use for my floors. I thought that we could tape straws across each floor and that it would be sturdy. The paper really helped us because it saved us some straws.
Light duty earthquake, testing 2 and 2 for 4.
An XYZ graph is a graph created by the motion and movement from the tower. X is the side-to-side movement of the tower, Y is the movement coming and going away from you, and Z is the up and down movement, also known as the tower's bouncing.
Our tower held 16 bags. That's about 1,600 grams. It took 7 attempts until our tower collapsed. We were very surprised about how it stood though. Our tower filled in the point of the crossbars where the 2 straws met. We did not have enough tape and we bent the straw too many times, so that made the tower a lot weaker. So we needed more tape. We needed to be more careful when we were making the tower because we kept bending them. And I also noticed that when the tower was shaking, it kept bouncing off the cardboard. So that made it collapse even easier. So I learned that we have to be smart with limited supplies. You only have to put the strengthening in the places that actually need strengthening. And you can be very creative when you decorate your tower. So that was really fun. I liked that we got to be collaborative and work with our friends to build this wonderful tower. And we got to have the experience of an architect. We got to be very creative and we got to have the perspective of a builder of earthquake-proof buildings.
Our tower held approximately 16 sandbags before it fell. I think our tower failed because our X joints weren't strong enough and they couldn't keep up with the vertical joints that were already bending. Our tower snapped from the bottom and the tower collapsed. If Tirel and I had made the cross joints a bit stronger, our tower would have been much more stronger. The cross joints would have held up the vertical joints longer and then we could have added more sandbags. The building codes help your tower actually because when we put in our foundation bolts, which were required, they actually helped the tower keep to the base longer. And so the foundation bolts really helped because they kept the tower down while it was shaking and it actually helped the tower to stay up before it collapsed. I think this project was really fun because we got to see a builder's perspective and all the building codes and things that they have to learn and apply to the building before they just make a building. It's so much more complicated than just adding a few straws and tape. You really have to think about what skills you're going to use and what technique you think will be best for your tower.